Progress. Welcome back. This is John Allison from Arkansas Lane. I'm going to work the last problem on the AP Calculus exam from Release FRQ from 2025. Remember, I do this cold. I've not worked these problems before. I've not looked at them before. I'm going to open them when I put this document camera on and let you see my paper. If I make mistakes, I hope you'll call me out on them. I hope you will critique me in the comments and let me know what you think. So we're going to find this. I'm not going to post here pictures of the problems because it's a copyright violation for College Board. I am including in the description to this video the link to the problem. Here we go. Question number 6. Consider the curve G defined by the equation y cubed minus y squared minus y plus 1/4 x squared equals 0. We're asked in part A to show that dy dx equals negative x over 2 times 3y squared minus 2y minus 1. So let's get to work on that. So let's take the derivative of the differential equation and get 3y squared dy dx minus 2y dy dx minus dy dx plus 2 times 1/4 is 1/2 x equals 0. I'm going to factor out the dy dx. Plus the 1/2 x. And now I'm going to subtract the 1/2 x from both sides. Go ahead and put that as x over 2. Divide both sides by 3y squared minus 2y minus 1. And get dy dx equals x over 2 times 3y squared minus 2y minus 1. So we have verified part A. Part B, so there's a point on the curve G near 2, -1 with x coordinate 1.6. Near 2, -1 with x equal 1.6. Use the tangent line to the curve 2, -1 to approximate the y coordinate at point P. So let's do this. Let's say dy dx. Go ahead and do this. All right. Dy dx at x equals 2 is equal to 2 over 3. Oh, so it's 2 times. I'll put -1 here squared, I get 3. When I put -1 in for y here, I get plus 2. And then minus 1. So this is 2 over, this is 5 minus 1 or 4 times 2, which is 8. So dy dx is 1/4. That means I can use a tangent line approximation and do y minus -1 or y plus 1 equals the slope dy dx times x minus 2. That implies that y equals 1/4 times x minus 2 minus 1. And we want to use this to approximate v when x equals 1.6. So the approximation for g, that x equals, that's the y value. at x equals 6, or so x equals 1.6, y is approximately equal to 1/4 times 1.6 minus 2 minus 1. I'm going to leave it like that because I don't have to do anything else with it at this point. That has sufficiently answered question B, and I could type it into a scientific calculator and it would give me the correct answer, so I'm going to leave it like that. Now I'm going to work on part C. For x greater than 0 and y greater than 0, there's a point S on the curve G at which the tangent line to the curve at that point is vertical. Find the y-coordinate of point S. So this is when x and y are both positive. So this is going to happen when dy dx is undefined. That's when you're going to get a vertical tangent. Not always, but you could get a vertical tangent. So we're going to solve for when the denominator here is 0. So we're going to set 3y squared minus 2y minus 1 equals 0 and solve. And that's going to give me, let's see here, that's going to be 3y and y. And we're going to have a plus and a minus. We're going to get minus 1 and plus 1 here. 3y squared minus 3y plus 1 makes minus 2y. Plus 1 times negative 1 makes negative 1. That's correct. That means y will equal negative 1/3 or y equals 1. We're only concerned with y greater than 0. So we're going to look at when y equals 1. We're going to go back to the original curve. We're going to plug in 1 minus 1 minus 1 plus 1/4 x squared equals 0. This is going to be minus 1 plus 1/4 x squared equals 0. This is going to be negative 4 plus x squared equals 0. X squared equals 4. So that we're only concerned with x greater than 0. So x equals 2 because we know x is greater than 0. Find the y-coordinate of point S. That's all we have to do is find the y-coordinate. So the y-coordinate is equal to 1. Okay, that works. We probably needed to verify anyway that was where x is equal to 0. Or x is greater than 0. Make sure you can see part D. Yeah, we'll be able to see part D. Particle moves along the curve 8. Defined by the equation. So here we have a curve 8. 2xy plus lny equals 8. At the instant when the particle is at the point 4, 1, dy dt is dx dt equals 3. We have to find dy dt. Okay, let's take the derivative of this. So we're going to get 2x times dy dt plus 2 times y, product rule, chain rule, plus 1 over y times dy dt equals 0. Taking the derivative of that. That's going to give us the curve for h prime. We're going to move everything that does not have a y. So I'm going to go ahead and subtract the 2y. I'll get 2x dy dt plus 1 over y dy dt equals negative 2y. I'm going to factor out the dy dt. You know what? I didn't do. dy dt, dx dt. This should be dx dt. Let's scratch this work. Because we're taking a derivative with respect to t, we have to do the chain rule on the x also. We can plug everything in now. I'm going to rewrite this over here a little clearer. 2x dy dt plus 2y dx dt plus 1 over y dy dt equals 0. Now I'm going to substitute everything in. I've got the 0.41. I've got dx dt. So x is 4. That's going to be 8 dy dt. 2 times 1 is 2. Dx dt is 3. So this is going to be 6. Y is 1. So it's going to be plus dy dt equals 0. I'm going to subtract 6 from both sides. I'm going to factor out the dy dt. We could have made it 9 dy dt. Goodness gracious. Make life hard on yourself, boy. So dy dt is equal to negative 6 over 9, or negative 2/3. Goodness gracious. Let's make that clear. And that should be question number 6. And that's it for the AB exam. We'll solve the 3 problems on the BC exam tomorrow.